It was the morning of January 28, 1986, and the air was electric with anticipation. The entire world was watching as the Space Shuttle Challenger prepared for liftoff. The mission was seen as groundbreaking, not only because it would carry astronauts into space, but also because it would carry Krista McAuliffe, a schoolteacher, who was selected to become the first civilian to fly into space. For years, NASA had been pushing the idea of bringing more ordinary citizens into the space program, and McAuliffe's mission was the pinnacle of that ambition. The Challenger was set to symbolize the future of space exploration, one that was inclusive, accessible, and democratic. The shuttle sat on its launch pad, poised to ascend, and millions of eyes around the globe were fixed on it. A feeling of excitement and pride filled the air, mixed with a deep sense of awe at the feat humanity was about to accomplish. However, as the countdown ticked away and the clock reached T-30 seconds, something was amiss. Behind the scenes at NASA, a series of critical warnings were being ignored, warnings that would ultimately lead to one of the most tragic events in modern history. Inside NASA's Operations Center, engineers were growing increasingly concerned about the unusually cold temperatures that had settled over Cape Canaveral. The shuttle was scheduled to launch in freezing conditions, and the engineers knew this could cause problems with the shuttle's solid rocket boosters, specifically with the O-rings, a critical component designed to prevent hot gases from escaping during the launch. These O-rings had never been tested under such extreme cold, and the engineers were fearful that the seals might fail, leading to catastrophic consequences. Yet despite these warnings, the launch proceeded. Minutes before liftoff, the engineers were still desperately trying to get through to the decision-makers. A group from Morton Thiokol, the contractor responsible for building the solid rocket boosters, urged NASA to delay the launch. They argued that the cold temperatures could cause the O-rings to become brittle and fail, potentially allowing fiery exhaust to escape from the boosters. But their warnings fell on deaf ears. NASA, under immense pressure to meet deadlines and avoid another delay, pushed ahead with the launch. After all, this mission was symbolic, the first to send a civilian into space. The media was already there, ready to broadcast the event to the world. The decision was made, and the shuttle launched. The world held its breath as the engines roared to life, lifting the Challenger off the ground. The shuttle ascended slowly, gaining speed, and for the first few seconds, everything seemed perfect. There was a brief moment when the mission appeared flawless, and it felt as though history was being made. But as the shuttle soared higher into the sky, something went terribly wrong. At 73 seconds into the flight, the Challenger began to break apart, disintegrating in a fiery explosion. The image of the shuttle bursting into flames as it plummeted toward the Earth became an indelible moment in history, searing itself into the collective memory of millions of people. In that instant, 7 lives were lost, including Krista McAuliffe, the teacher who had dreamt of becoming the first civilian in space, and 6 astronauts who had dedicated their lives to the exploration of the unknown. The explosion sent shockwaves through the world. People couldn't believe what they had just witnessed. How could something so horrific happen? How could NASA, an agency synonymous with success, allow such a disaster to unfold? It didn't take long before questions began to swirl. What went wrong? Why did the shuttle explode? And why had the engineers' warnings been ignored? In the days and weeks that followed, investigations into the disaster began. The Rogers Commission, established to determine the cause of the disaster, would reveal some of the most shocking details that many within NASA had hoped to keep hidden. But while the Commission's findings would bring some clarity to the public, they would also raise even more questions about the decisions that led to the Challenger disaster. Despite the official cause of the explosion being attributed to the failure of the O-rings in the cold weather, the truth behind the disaster runs much deeper. The O-rings were just the visible symptom of a much larger problem, one of management failures, miscommunication, and a reckless disregard for the safety of the astronauts aboard. NASA was facing intense pressure to deliver on the promises it had made. The shuttle program had been plagued by delays and cost overruns, and the Challenger mission was seen as a critical point in proving that the shuttle program could be successful. The public was already skeptical of the shuttle's reliability, and NASA's leadership knew that another delay could be disastrous for the program's future. But in their rush to prove themselves, they overlooked critical safety concerns. NASA's management prioritized meeting deadlines and public relations goals over the lives of the astronauts, a decision that would ultimately cost them dearly. The Challenger disaster was, at its core, a tragedy caused by the failure of the O-rings in the solid rocket boosters. These small rubber seals were supposed to keep hot gases contained within the boosters during the launch. However, the cold temperatures on the morning of January 28 caused the O-rings to become brittle, making them more susceptible to failure. When the shuttle launched, the heat from the rocket's engines caused the O-rings to fail, allowing hot gases to escape. This led to the destruction of the booster's aft field joint attachment, which, in turn, caused the explosion that shattered the shuttle and killed the 7 astronauts aboard. But the true story of the O-rings is more complex than a simple mechanical failure. Behind the O-rings was a history of warnings, ignored memos, and internal battles within NASA and its contractors. Engineers at Morton Thiokol, who had designed and built the boosters, knew that the O-rings could fail in cold weather. They had raised alarms about this issue long before the Challenger launch. In fact, in previous flights, they had observed minor damage to the O-rings that had been dismissed by NASA's management as insignificant. But as the temperatures dropped in the days leading up to the Challenger launch, the engineers became increasingly worried. They were concerned that the O-rings would not be able to perform under such extreme conditions. They made their case to NASA's decision-makers, urging them to delay the launch until the weather warmed up. But NASA had already made up its mind. The mission was going to launch, no matter the risk. On the night before the launch, engineers at Morton Thiokol had made their final attempt to persuade NASA to delay. They had conducted simulations and gathered data showing the risks posed by the cold. But NASA was unrelenting. The pressures of the mission were too great. The shuttle program needed a success, and the Challenger mission was too important to delay. NASA's leadership was already under fire from the media and the public for the delays and budget overruns of the shuttle program. They couldn't afford another postponement. So, against the engineers' warnings, they pushed ahead with the launch, but there was another factor at play here. An institutional culture at NASA that downplayed risk and emphasized the need to get the job done. In the days leading up to the disaster, there were multiple warnings from engineers at Morton Thiokol and even from within NASA itself. But these warnings were routinely brushed aside. The engineers were not in charge of the decision to launch. NASA's leadership was. And they had their eyes firmly fixed on meeting the deadline, no matter the cost. The decision to ignore the warnings about the O-rings and proceed with the launch was a fatal one. But the worst part was that it wasn't just a single decision, it was a pattern of behavior at NASA, a systemic issue that had been allowed to persist for years. As the shuttle's launch date approached, the pressure on NASA was mounting. The agency had invested billions into the shuttle program, and the Challenger mission was seen as a crucial milestone. The shuttle was supposed to be a reusable spacecraft that would revolutionize space travel, drastically reducing the cost of getting to space. But the program had been plagued with delays, technical problems, and budget overruns. NASA needed to prove that the shuttle program was not only viable but also reliable. The Challenger mission had become symbolic of NASA's ability to overcome its challenges and deliver on its promises. At the same time, the public's enthusiasm for space exploration was waning. The shuttle program was no longer the cutting-edge technology that it had once been. The world was changing, and NASA was struggling to keep up. There was a growing sense of urgency within the agency to prove that the shuttle was still the future of space travel. The Challenger mission, with Krista McAuliffe on board, represented a chance to reinvigorate public interest in space. But that pressure to succeed came at a terrible cost. As the launch date approached, NASA's leadership became more and more focused on the optics of the mission rather than the reality of the risks. The decision to proceed with the launch, despite the concerns raised by engineers, was a reflection of this intense pressure. It was a decision driven by the desire to meet deadlines and project an image of success, not by a genuine assessment of the risks involved. In the end, that decision would lead to tragedy. The Challenger exploded, and 7 astronauts lost their lives. The disaster was a wake-up call for NASA, but it also exposed a deeper, more troubling issue, an institutional culture that prioritized appearances over safety, that valued success over truth. As the Challenger ascended, there was no sign of immediate trouble, at least, not to the untrained eye. From the ground, the launch appeared normal. The crowd, including the families of the astronauts and hundreds of schoolchildren watching Krista McAuliffe's historic journey, cheered as the shuttle soared into the sky. The newscasters marveled at the moment, reinforcing NASA's narrative that this was a triumph for space exploration. But inside NASA's mission control, unease was growing. Instruments monitoring the solid rocket boosters displayed anomalies. A small puff of black smoke was seen trailing from the right booster within the first few seconds of flight, an early sign that the O-rings were already failing. However, in the rush of the moment, no alarms were raised. The excitement of the launch overshadowed the hidden danger brewing beneath the shuttle. Then, just 73 seconds after liftoff, disaster struck. The world watched in horror as the Challenger suddenly disintegrated mid-air. The massive explosion sent fiery debris hurtling toward the ocean, and what had been a moment of triumph instantly turned into an unfathomable tragedy. For several seconds, there was silence, both in the control room and among the crowds watching from the ground. No one wanted to believe what had just happened. But as the shuttle's remains fell from the sky, reality set in. Christa McAuliffe, the teacher who had inspired millions of students with her dream of reaching space, was gone. So were Francis Scobie, Ronald McNair, Michael Smith, Ellison Onizuka, Judith Resnick, and Gregory Jarvis. As Mission Control scrambled for answers, a chilling realization dawned on some of NASA's engineers. This was exactly what they had feared. They had warned management that the O-rings wouldn't hold in the freezing temperatures. They had begged for the launch to be delayed. And yet, their voices had been ignored. Now, 7 people had paid the ultimate price for a decision that had been entirely preventable. For the public, it seemed like a tragic accident, a devastating but unforeseeable event. But within NASA, many knew the truth. This was no accident. This was a failure of leadership, a disaster caused by negligence, corporate pressure, and a reckless disregard for safety. Within hours of the explosion, the world was in mourning. News outlets replayed the horrifying footage over and over, and for the first time, NASA, an institution synonymous with success and technological excellence, was on the defensive. Questions began to swirl. What had gone wrong? How could this have happened? President Ronald Reagan was scheduled to deliver the State of the Union address that evening. Instead, he postponed it and addressed the nation in a somber speech, offering condolences to the families of the astronauts. He assured the public that NASA would investigate and that the sacrifices of those aboard the Challenger would not be in vain. But behind the scenes, NASA was in full damage control mode. The agency's leadership knew they had a problem, one that could destroy public trust in the shuttle program. If it became known that they had ignored engineers' warnings and proceeded with a launch under dangerous conditions, the consequences would be catastrophic, not just for NASA's reputation, but for its future funding. Immediately, NASA began shaping the narrative. They released carefully worded statements suggesting that the explosion had been an unforeseen mechanical failure, something that could not have been predicted. Internally, officials scrambled to downplay the role of the O-rings. Some even pressured engineers to remain silent about their warnings before the launch. The truth was dangerous. If the world knew that NASA had pushed forward despite knowing the risks, the outrage would be immense. Meanwhile, the families of the fallen astronauts demanded answers. Christa McAuliffe's husband, Steve McAuliffe, was devastated. The families of the other crew members were equally grief-stricken, and some of them were beginning to ask questions NASA wasn't prepared to answer. NASA promised an independent investigation, but insiders already knew that much of what had happened would be buried in bureaucracy, classified documents, and carefully controlled testimonies. But there was one problem NASA hadn't accounted for. Someone was about to blow the whistle. Amid the chaos, President Reagan announced the formation of the Rogers Commission, a panel tasked with investigating the cause of the Challenger disaster. The commission included high-profile officials, former astronauts, and engineers, but one man stood out among them, Dr. Richard Feynman. Feynman, a brilliant physicist known for his blunt honesty and relentless pursuit of truth, was not interested in political games. Unlike others on the commission, he wasn't willing to let NASA control the investigation. From the start, he sensed that something wasn't right. NASA's explanations were vague. Their responses were rehearsed. And the deeper he dug, the more contradictions he found. Then came the moment that would change everything. During a televised hearing, Feynman performed a simple but devastating experiment. He dropped a small piece of an O-ring into a glass of ice water, then pulled it out and bent it. The rubber, which was supposed to be flexible, had become brittle and cracked. In that single demonstration, Feynman had exposed the fatal flaw. NASA had launched the Challenger in freezing conditions, knowing that the O-rings wouldn't function properly. The truth was out. NASA's attempt to control the narrative had failed. The Rogers Commission's final report confirmed what many had suspected. NASA's leadership had ignored engineers' warnings, dismissed critical concerns, and allowed bureaucratic pressure to override safety. The Commission criticized NASA's culture of recklessness and called for significant reforms. But for the families of the fallen astronauts, the damage was already done. Their loved ones had died not because of a freak accident, but because of negligence, arrogance, and a failure to listen. While the Rogers Commission exposed much of NASA's failure, there were aspects of the disaster that were never fully revealed to the public. One of the most chilling revelations came years later. The crew of the Challenger likely did not die in the initial explosion. Evidence suggested that the crew cabin had survived the blast intact and had continued to ascend before plummeting back to Earth. Some experts believe that at least some of the astronauts were conscious as they fell, trapped in a doomed vessel with no chance of survival. NASA has never confirmed the full extent of this possibility. But if true, it would mean that the crew spent their final moments fully aware of what was happening, knowing they had been failed by the very agency they had dedicated their lives to. In the years following the disaster, NASA implemented changes to improve safety, but the stain of the Challenger disaster has never fully faded. The lessons learned were costly, and for some, they came too late. The Challenger disaster wasn't just a tragedy, it was a warning. A warning about what happens when ambition overrides caution, when bureaucracy ignores expertise, and when the pursuit of success blinds people to the dangers staring them in the face. For decades, NASA tried to move past the Challenger disaster. But the truth remains, hidden in ignored warnings, silenced voices, and a history that cannot be rewritten. And for those who look deeper, the real question remains: if this could happen once, could it happen again?